Electrical connections require proper torque to prevent hot spots and ensure reliable performance. Torque tables provide recommended torque values for electrical connections based on the size and type of screw, as well as the material of the conductor. One resource for this information is the National Electrical Manufacturers Association, or NEMA, which publishes power cable and wire ampacities and recommended torque values for electrical connections. This document contains tables listing recommended torque values for various combinations of screw size, conductor material, and conductor size. For example, a number 10 copper conductor using a number 8 screw requires a torque of 17 inch-pounds. Similarly, a number 12 aluminum conductor using a number 10 screw requires a torque of 15 inch-pounds. These values serve as guidelines. The ideal torque may differ based on the specific scenario. Always check with the electrical equipment manufacturer or a certified electrician for precise torque specifications for your connection. When tightening screws on electrical connections, several factors influence the appropriate torque value. Firstly, the screw size is critical. Larger screws typically require higher torque values to achieve a secure connection. The screw's material composition also matters. For instance, stainless steel screws may have different torque requirements than those made of carbon steel. Secondly, the conductor material significantly impacts the torque needed. Copper conductors, known for their excellent conductivity, might require different torque settings than aluminum conductors, which are lighter but can oxidize. Thirdly, the conductor size plays a crucial role. Thicker conductors generally need higher torque to ensure a tight and reliable connection. Furthermore, the type of connection itself matters. Different types of connectors, such as compression connectors, set screw connectors, or lug connectors, have specific torque requirements to achieve optimal performance. The environment where the electrical connection is located can also affect torque requirements. Connections exposed to vibration or extreme temperatures may need high torque to maintain their integrity over time. It's essential to consult relevant standards and guidelines. Standards such as those published by the National Electrical Code, known as NEC, or other relevant industry standards provide valuable information on recommended torque values for various electrical connections. The NEC is a widely adopted code that sets the standard for safe electrical installation and inspection to protect people and property from electrical hazards. Proper torque is vital for several reasons. Insufficient torque can lead to loose connections, causing increased resistance and heat generation, which can result in hot spots, insulation damage, and even electrical fires. Over-tightening, on the other hand, can strip the threads of the screw or damage the conductor, compromising the connection's integrity. Both scenarios can lead to connection failure and potentially dangerous situations. Using a calibrated torque wrench is essential to ensure accurate torque application. Torque wrenches come in various types, including mechanical and digital versions. Calibration ensures that the wrench provides accurate readings, preventing under or over-tightening. Regularly inspect torque wrenches for wear and tear and recalibrate them as needed to maintain their accuracy. It is also important to follow a consistent tightening pattern when multiple screws are involved in a connection. A common method is to tighten the screws in a star pattern, gradually increasing the torque on each screw until the desired value is reached. This ensures even pressure distribution across the connection and prevents distortion or stress on any one point. Besides torque, proper surface preparation is crucial for reliable electrical connections. Clean the contact surfaces of both the conductor and the connector to remove any dirt, corrosion, or oxidation. A clean surface provides better conductivity and reduces the risk of hot spots. Applying an anti-oxidation compound can further enhance the connection's reliability, especially for aluminum conductors. These compounds create a protective barrier that prevents oxidation, ensuring a stable and long-lasting connection. Always adhere to the manufacturer's instructions when using anti-oxidation compounds, as improper application can have adverse effects. Additionally, consider the type of environment where the electrical connection will be located. In corrosive environments, such as those with high humidity or exposure to chemicals, use corrosion-resistant connectors and hardware. These materials are designed to withstand harsh conditions and prevent degradation of the connection over time. Regular maintenance and inspection are crucial for ensuring the long-term reliability of electrical connections. Periodically check connections for signs of looseness, corrosion, or damage. Use thermal imaging to identify hot spots, which can indicate a loose or failing connection. Address any issues promptly to prevent further damage or potential hazards. When performing maintenance or repairs on electrical connections, always de-energize the circuit before working on it. Follow lockout/tagout procedures to ensure that the circuit remains de-energized while work is being performed. This prevents accidental energization and protects against electrical shock. Furthermore, ensure that all personnel working on electrical connections are properly trained and qualified. Electrical work should only be performed by individuals who have the necessary knowledge, skills, and experience to do so safely and effectively. Training should cover topics such as electrical safety, proper tool usage, torque application techniques, and relevant codes and standards. The type of enclosure or junction box used for electrical connections also plays a role in ensuring safety and reliability. Enclosures should be appropriately rated for the environment in which they are installed, providing protection against moisture, dust, and other contaminants. Using the correct type of enclosure helps prevent corrosion and ensures that the connections remain secure and protected. Selecting the right type of connector for the application is also important. Different types of connectors are designed for different types of conductors and applications. For example, compression connectors are commonly used for high-voltage applications, while set screw connectors are often used for smaller gauge wires. Ensure that the connector is compatible with the conductor size and material and that it is properly installed according to the manufacturer's instructions. Furthermore, proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Ensure that all electrical connections are properly grounded according to the NEC and other relevant standards. Grounding conductors should be sized appropriately and securely connected to the grounding electrode system. Another consideration is the use of surge protection devices. Surge protection devices protect electrical equipment from voltage spikes and surges, which can damage sensitive electronics and cause equipment failure. Install surge protection devices at the service entrance and at individual equipment locations to provide comprehensive protection against voltage surges. Regularly inspect surge protection devices to ensure that they are functioning properly. In addition to these technical considerations, it is also important to follow best practices for electrical safety. Always wear appropriate personal protective equipment such as safety glasses, gloves, and insulated tools when working on electrical connections. Keep the work area clean and organized to prevent accidents and ensure that all tools and equipment are in good working order. Never work on live electrical circuits unless absolutely necessary, and always follow lockout/tagout procedures to ensure that the circuit remains de-energized while work is being performed. Proper documentation is also crucial for electrical connections. Keep records of all electrical work performed, including torque values, conductor sizes, and connector types. This information can be valuable for troubleshooting and maintenance purposes and can help ensure that the electrical system remains safe and reliable over time. Regularly review and update electrical documentation to reflect any changes or modifications to the system. By following these best practices and paying attention to detail, electricians can ensure that electrical connections are made safely and reliably, minimizing the risk of hotspots, equipment failure, and electrical hazards. Remember that electrical work should only be performed by qualified individuals who have the necessary training and experience to do so safely and effectively. The NEMA document provides comprehensive guidelines for electrical connections, including torque values for various conductor and screw combinations. In addition to NEMA, other organizations such as the Institute of Electrical and Electronics Engineers, also known as the IEE, and Underwriters Laboratories, known as UL, provide standards and guidelines for electrical connections. These standards cover various aspects of electrical connections, including materials, construction, and performance requirement. Consulting these standards can help ensure that electrical connections are made in accordance with industry best practices. When selecting connectors for electrical connections, consider the environmental conditions in which the connections will be used. In wet or corrosive environments, use connectors that are specifically designed for those conditions. These connectors typically have special coatings or materials that protect against corrosion and moisture damage. Using the appropriate connectors can help ensure that the connections remain reliable over time. Proper cable management is also important for electrical connections. Cables should be neatly organized and supported to prevent strain on the connections. Use cable ties or other supports to keep cables in place and prevent them from rubbing against sharp edges or other objects. Proper cable management can help extend the life of electrical connections and prevent damage to the cables. When making electrical connections, be sure to follow the manufacturer's instructions for the specific connectors being used. The manufacturer's instructions will provide detailed information on how to properly install the connectors, including torque values, stripping lengths, and crimping procedures. Following the manufacturer's instructions can help ensure that the connections are made correctly and that they will perform reliably over time. Regular inspection and testing of electrical connections are essential for maintaining their reliability. Inspections should be performed periodically to check for signs of looseness, corrosion, or damage. Testing can be performed using various methods such as thermal imaging, voltage drop testing, and insulation resistance testing. These tests can help identify potential problems before they lead to equipment failure or electrical hazards. When troubleshooting electrical connections, it is important to have a systematic approach. Start by visually inspecting the connections for signs of looseness, corrosion, or damage. Then, use a multimeter or other testing equipment to check for voltage, current, and resistance. Compare the measurements to the expected values to identify any problems. Once the problem has been identified, take corrective action to repair or replace the connection. Proper grounding is critical for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Ensure that all electrical equipment is properly grounded according to the NEC and other relevant standards. Grounding conductors should be sized appropriately and securely connected to the grounding electrode system. Surge protection devices are also important for protecting electrical equipment from voltage spikes and surges. Surge protection devices divert excess voltage away from sensitive electronics, preventing damage. Install surge protection devices at the service entrance and at individual equipment locations to provide comprehensive protection against voltage surges. Regularly inspect surge protection devices to ensure that they are functioning properly. Electrical safety training is essential for all personnel who work on electrical equipment. Training should cover topics such as electrical hazards, safe work practices, and the proper use of personal protective equipment. Employees should be trained to recognize and avoid electrical hazards and to follow safe work practices at all times. Electrical safety audits can help identify potential hazards and ensure that safe work practices are being followed. Audits should be performed periodically by qualified individuals who are familiar with electrical safety standards and regulations. The results of the audit should be used to develop and implement corrective actions to address any identified hazards. By following these best practices and paying attention to detail, electricians can ensure that electrical connections are made safely and reliably, minimizing the risk of hot spots, equipment failure, and electrical hazards. The NEC is a comprehensive set of standards for electrical installations. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect changes in technology and industry best practices. Staying up to date on the latest edition of the NEC is essential for ensuring that electrical installations are safe and compliant. State and local electrical codes may also apply to electrical installations. These codes may be more stringent than the NEC in some areas. It is important to be familiar with the applicable state and local codes before starting any electrical work. Permits are typically required for electrical work. Permits are issued by local building departments and are used to ensure that electrical work is performed in accordance with applicable codes and standards. Obtaining a permit before starting electrical work can help avoid costly fines and delays. Inspections are typically required after electrical work is completed. Inspections are performed by local building inspectors to ensure that the work has been performed in accordance with applicable codes and standards. Passing an inspection is required before the electrical system can be energized. The proper selection and installation of electrical equipment are critical for safety and reliability. Electrical equipment should be selected based on the specific application and should be installed according to the manufacturer's instructions. Electrical equipment should also be properly maintained to ensure that it continues to operate safely and reliably. Regular maintenance should include cleaning, lubrication, and inspection. Faulty electrical equipment should be repaired or replaced promptly. Safety interlocks are used to prevent accidental contact with energized electrical equipment. Safety interlocks are typically used on high voltage equipment and other equipment that poses a significant electrical hazard. Safety interlocks should be regularly inspected and tested to ensure that they are functioning properly. Warning signs are used to alert personnel to electrical hazards. Warning signs should be placed in conspicuous locations and should be easily visible. Warning signs should be used to warn of hazards such as high voltage, arc flash, and electrical shock. Personal protective equipment, or PPE, is used to protect personnel from electrical hazards. PPE includes items such as safety glasses, gloves, and insulated clothing. PPE should be selected based on the specific hazards present and should be properly maintained. Arc flash is a dangerous phenomenon that can occur when electrical equipment fails. Arc flash can produce intense heat, light, and pressure, which can cause serious injuries or death. Arc flash protection is required for personnel who work on or near energized electrical equipment. Arc flash protection includes items such as arc-rated clothing, face shields, and gloves. Lockout/tagout procedures are used to prevent accidental energization of electrical equipment. Lockout/tagout procedures require that electrical equipment be de-energized and locked out before any work is performed. Lockout/tagout procedures should be followed whenever working on or near electrical equipment. First aid and CPR training are essential for personnel who work on electrical equipment. First aid and CPR training can help save lives in the event of an electrical accident. Employees should be trained to recognize the signs and symptoms of electrical shock and to provide appropriate first aid. Emergency procedures should be in place in the event of an electrical accident. Emergency procedures should include steps such as calling for help, providing first aid, and shutting off the power. Emergency procedures should be practiced regularly to ensure that everyone knows what to do in the event of an accident. Regular safety meetings can help reinforce electrical safety awareness and promote a safe work environment. Safety meetings should be held regularly and should cover topics such as electrical hazards, safe work practices, and emergency procedures. Employees should be encouraged to ask questions and share their concerns. By following these best practices and paying attention to detail, electricians can ensure that electrical connections are made safely and reliably, minimizing the risk of hotspots, equipment failure, and electrical hazards.